Hello, everybody, and thank you for joining us today. My name is Jake Stakowitz, and I am excited to be here today giving my first ever webinar with Golden Software. I'm going to be talking about how to create a site suitability model in Surfer. And so today we're going to cover what a site suitability model is and how it works, how to manipulate your grid files for the suitability model using grid math and grid calculus, and how to make the model look more professional using Surfer's feature editing tools like Thiessen Polygons, Query, and Buffer. After the discussion of each topic, I'm going to stop for a few minutes to answer any questions. You can send your questions to the webinar host via the Q&A located on the Zoom toolbar at any time. Type in your question and it'll be sent to the webinar host, who will either answer it or forward it to me. And please use the Q&A function rather than the chat. This is going to allow the host to ensure that we see all the questions in a timely manner. Feel free to send in all your questions, and if we don't have time to answer them during the webinar, we're going to answer them via email once the webinar is complete. And this webinar is being recorded, so later this week we're going to post the recording along with the data used in the webinar. We'll send each of you a link when it's posted so you can test these examples out for yourself. And now let's get started. First, I'm going to cover what a site suitability model is. A site suitability model is a model that weights different spatial locations relative to each other based on a given criteria, and then it highlights those areas that best meet your criteria. These models are typically used to help guide the decision-making process for determining the most favorable locations of things such as a new business, road, or a landfill. Site suitability models can be applied across a number of different industries, such as construction, urban planning, and natural resource management. A suitability model can be created in Surfer by reclassifying your grid files and overlaying them to highlight where the areas with your desired criteria overlap. In the model we create for this webinar, we will classify our grids to either a 1, where areas meet our criteria, or a 0 for areas that don't meet our criteria. Once our grids are in a binary format, they can be added together to create a suitability grid that shows the optimal location per input criteria. Once we build this grid, the areas with higher scores will be considered more favorable to build our new storefront at, and lower scores less favorable. We'll then take our model to the next level by incorporating Thiessen Polygons to further break down the most suitable locations identified in the previous steps. So now let's dive into our example that we have on screen currently. The model we're going to make today is to determine the best location for a new storefront of a popular department store chain. Right now, we're looking at an aerial photograph of the predetermined area that we can build in, overlaid with a contour map showing the elevation of the area. We also have a base map showing all the roads in the area, and the white dots are the already existing storefronts of our chain in the area. So after seeing what we have to work with, let's take a look at the criteria for choosing the best site of our new store location. First, we're looking for a location where the elevation is less than 2,500 meters. We also want the store to be located in an area with a gentle slope, as construction costs rise when building on slopes steeper than a 10% grade. Our new store would like to install solar panels, so a location with high exposure to the south and west is ideal. And our store needs to be within 1,000 meters of a major highway. Finally, if possible, we would like to be located in an area of need to relieve pressure on some of our other local storefronts. So now let's get started with our first set of criteria, which is elevation. Like I just said, we're looking for a site with an elevation of less than 2,500 meters. The already overlaid contour map is displaying all the areas under 2,500 meters. But to incorporate this into our site suitability model, we must classify all the values in our grid file as either a 1 or 0, with 1 being areas under 2,500 meters and 0 being anything over 2,500 meters. This can be easily done in Surfer from the Grids tab. Then we navigate to the Calculate section and click the Math command. Now we have the Grid Math window open, and I'm going to add the grid file that I used to create this contour map. Surfer is going to automatically set the variable to A, but we can change it to anything we want. So I'm going to set it as elev for elevation. And this is handy if you're working with multiple grids in the same project, which we are, to set them apart and use in more complex functions. The first function is not too complex though. It is if elif is less than or equal to 2500, comma 1, comma 0, close the parentheses. And to break down exactly what this means, elif of less than or equal to 2500 meters is our true false statement. So if it is true that our elevation is less than or equal to 2500 meters, the grid node will be assigned a 1. And if it is false that elif is less than or equal to 2500 meters, the grid node will be assigned a 0. And so now we can go ahead and name our output grid target elevation. I'm going to add it as a new layer, a new color relief layer. Press OK. Bring that up to the top. And now we have a color relief map where all of the blue areas are our 1s and all of the green areas are our 0s. I'm going to go ahead and change this terrain representation to color only. For our purpose of working in a binary situation, it makes more sense to have distinct colors without shading. And then we're also going to change our color map since this widespread of colors doesn't really work when we want values between 0 and 1. So I'm going to change it to a more simple color map, which is going to be this construction option here at the bottom. And now we can see our most suitable areas are in red and the less so are in green and yellow. And now we still have 2 more grids to make, but first I want to take a quick break to address any questions that we have so far. All right, so it looks like somebody asked how come Surfer filled in the equation as I typed in the grid math dialog. That's because the grid math dialog is sticky and Surfer remembers what you've entered in the past. And since I've input that formula before, it remembers that I've input it before. Okay, and another question is how come I had to drag the layer after creating it? Surfer draws the layers in the order that they appear in the contents. So it just automatically added it to the bottom and I just have to bring it up to the top. All right, and thank you guys for sending those questions in. I'm going to go ahead and move on to our next bit of criteria. So let's open this criteria slide again. Also, guys, we'll be answering any questions that don't get answered during the webinar by email. All right, so the next bit of criteria is that we wanted to build at a spot where the slope was less than 10% grade. And so now to manipulate this grid, we're going to have to do one more step than just importing the formula into the grid math window. First, we're actually going to have to calculate the slope of the grid from the elevation grid. So we can do that with the calculus tool, which is located just to the left of the math tool right here in the calculate section. So I'm going to click on calculus. And this dialog lets us choose an open grid. So I'm going to select that original grid that we used earlier. And then here in the terrain modeling section, I'm going to choose terrain slope. And terrain slope calculates the slope at any given node on the surface and reports the slope in degrees from 0, which is horizontal, to 90, which is completely vertical. And Surfer is going to do all the math for us. So we just need to rename this grid, and I'm going to call it slope. I'm going to add it as a new layer to our new color relief layer to our map again. Bring that up to the top again. And for this layer, I'm going to actually put hill shaded back on since we're looking at slopes. And now that we have the slope calculated in this grid layer, we can use grid math to have Surfer classify our slopes as either above or below 10% grade. So again, on the grids tab, we're going to go back into this grid math window. And then this time I'm going to add that slope grid that we just made. And this time our equation is going to be pretty similar to the first one, but I'm going to keep the variable as a. And this time our true false statement is going to read as if it is true that A is less than or equal to 10, the grid node will be assigned a 1. And if it is false that A is less than or equal to 10, the grid node will be assigned a 0. Once this function is in, I'm going to name the output grid our target slope grid and add it as a new color relief layer again. And then I'm also going to change this color scheme to match our previous layer with construction. And now you guys can see that we've got a good amount of red area here, which is our most suitable areas. You can also see, just based off of these two criteria types, how difficult it would be to eyeball it and match these red areas together. And so that is why we are letting Surfer do that for us. And now we're going to move on to our next set of suitability criteria. So I'm going to bring this slide back. And we also wanted high exposure to the south and west in order to take full advantage of our installed solar panels. And so for this grid, we're going to have to use calculus again. So I'm going to click this calculus tool here in the grids ribbon. And I'm going to select that original grid again. And this time we're going to have Surfer calculate the terrain aspect of the grid. Terrain aspect calculates the downhill direction of the steepest slope, also known as the dip direction at each grid node. It is the direction perpendicular of the contour lines on the surface, and it is exactly opposite the gradient direction. Terrain aspect values are reported in azimuth, where 0 degrees is due north and 90 degrees is due east. East. You may also notice that the terrain aspect has this threshold field. This is used in areas where the steepest slope approaches 0, so the surface is nearly horizontal. In areas like this, the gradient direction can be difficult to obtain, so it is preferable to classify the surface as flat. The threshold value lets you set a minimum value for the slope that, if not met, assigns that area no data. Usually by default, the threshold value is set to a very small value, and we're good to keep it that way. And we can change the output name to aspect. And we're going to add it as a new color relief layer again. Bring that up to the top. And now we can take a look at our aspect grid and how it compares to those other two grids that we've made so far. I always think it's kind of interesting just to take a look at all the different ways that you can manipulate the same set of grid data. But now we can move on to classifying our aspect grid, which once again, we're going to be using this grid math tool for. This time our equation is going to be a bit different, but first I'm going to add the aspect grid that we just made. And so in this equation, we're going to be looking for a range of values instead of above or below a certain value. And we're going to be looking for values between 135 and 315 degrees, since that encompasses all values between south and west. So this equation is going to be if A is greater than, if A is greater than or equal to 135 degrees, and if A is less than or equal to 315 degrees, then the grid node will be assigned a 1. And if it falls outside of that range, the grid node will be assigned a 0. I'm going to go ahead and name this our target aspect grid. And we're going to add it as a new color relief layer again. And I'm also going to go ahead and change this color scheme to match our other grids. So I'm going to choose this construction option here at the bottom. I'm also going to turn on and No, actually, just now that we have all our grids created, so now we have all our grids created and we need to add them all together so that we can get an idea of our most suitable locations. As I explained before, our most suitable locations are going to have the highest values, but now since we're adding them together, our values are going to be between 0 and 3. So now for the last time, let's go ahead and hop into the grid math tool. And this time, let's add all of the target grids that we just made. And Surfer is going to automatically assign them the variables of A, B, and C. And this time our formula is going to be real simple. It's just going to be A plus B plus C. I'm going to call that our target combo grid. Add it as a new color relief layer again. Bring that up to the top. And we also want to assign this the construction color scheme. And now I'm going to turn on our color scale. And if you look at our color scale on the side here, you can see that right now our most suitable and nearly most suitable values are between 0.6 and 3. And that doesn't really match our data because we want our colors to have discrete values between 0, 1, 2, and 3. And so to fix this, I'm going to create a custom color map by clicking on these ellipses here in the property window. So now I'm in the color map editor. And like I said, we want to keep the 3 discrete colors. So first I'm going to delete this extra node right here. And then I'm going to click on the green color node, and I'm going to assign it a data value of 1. Then I'm going to click on our yellow. I'm going to assign that 0.99. Then I'm going to do the same thing at the 2. I'm going to click on our green. I'm going to assign it 1.99. I'm going to assign red 2. Now when I press apply, you can see that we have these nice discrete colors. And we also have a lot of red and green, which are our most suitable areas. So I think that we'll be fine actually taking yellow off this map. And we can do that once again in the color map editor here in the opacity mapping field. And so to do that, first I'm going to add 2 nodes on the opacity mapping line. Let's get that second node. And then I'm going to do that so that we can stack them. And I'm going to assign them both a value of 1. Oh. Okay. Then we're going to click on our first node. And we're going to assign it an opacity value of 0. And then we press apply. Okay. And when I turn off all the layers underneath this, we should be able to see all the way down to our original base layer, which we can. And now that we have the start of a nice suitability map, and with our roads and already existing store locations visible, we're really starting to get an idea of our best new storefront location. But now before moving on to our last 2 sets of criteria, do we have any more questions? All right, so somebody asked, where can you find more grid math functions, parameters, or variables to use in grid math? And so our functions and parameters can be found in Surfer's help page on the grid math page. That's a link, and we can send that out if needed. And then variables are set by the user, so you can define the variables as needed using as many characters that you want or just one. It's really up to your own discretion. All right. Thanks everybody for sending those questions in. To refresh our memory real quick, just want to remind everybody that the red areas in our suitability map are our most suitable. Based on our criteria so far, that's where we most want to build. And green is our slightly less suitable, but still meets some of our criteria. And now to refresh our memory on that criteria, I'm going to bring that slide up again. And so we also wanted to have our store within 1,000 meters of a major highway. And we already have a base layer with all of our roads on it. The roads are a little bit hard to see, so I'm actually going to up the line thickness here. And now that those are a little bit more visible, it's pretty clear that all of these roads aren't major highways. Some of these look like they could be neighborhoods, such as this pocket right here, maybe even like this pocket up here. And if anybody is wondering, we got this layer from the Colorado Transportation Department, and it's pretty large and it has a ton of polylines. So the best way to work within this layer is going to be from the attribute table. And we can open the attribute table by going to the Map Tools ribbon and then the Layer Tools section and clicking Open Attribute Table right here. And now we can see quite a bit of information about our base layer. A cool thing about the attribute table is that it's a modal dialog, which means if I click on this polyline right here, it's going to highlight the polyline in our attribute table, as well as highlighting it on the map right there. But now let's scroll through to our attribute of interest, which is road type right here. And we've got a couple different road types here. We've got major, local, neighborhood. And we know that we're interested in these roads that are classified as major. So now we're going to create a query to highlight all of the road types in this layer that are classified as major. And that's going to be easier than scrolling through this whole attribute table and selecting each instance of major. So I'm going to X out of this. And the query tool is located right here next to the layer tools section. And I'm going to go ahead and click that now. And that's going to bring up the query window. And related to that question earlier, Surfer remembers things that have been input before. And so Surfer remembers the query that I've put in here, but I'm still going to walk through it with you guys. And so when you bring up a query, you first select what type of objects you want to query up. And in this layer, we only have polylines, so we'll keep that selected. And when you make changes to your query, Surfer automatically writes the formula down here for you. And then over here on the right, on this drop-down menu, you can select what type of attribute you want to query up. And we know we want road type. Then on this drop-down menu, you would be able to select equals, less than, greater than, whatever is needed for the formula you're writing. And then in this bit, we would write what type of attribute, what the label for the attribute that we want to query is. And we know that we want major roads. So now that's ready. And in this drop-down menu right here, I'm going to select copy to new layer. Then I'm going to press OK. And now we have a query results of all of our major roads. If I click through this, you can see it highlights the various major roads that were in our base layer. And now that we have all of our major roads selected, we're going to be able to create a 1,000 meter buffer around these major roads. And so to create the buffer, first we're going to have to select all of the polylines in that query results layer. I just shift clicked to select all of those. And then we can click to the features ribbon and click on the buffer tool right here. And now that we're in the buffer window, you can choose to either add more rings around your buffer, or you can even change it to a negative number so that the buffer goes inward from your selected objects. But for our purposes, leaving it at 1 works well. Then we're also going to set the buffer distance to 1,000 units. the buffer tool is always going to set the units to the same as the layer that you're working in. And in our case, that's meters. So I'm going to go ahead and press OK. And now you can kind of see this faint outline of this buffer polygon that we just created. I'm going to go ahead and make that more visible by changing the color to yellow, upping the line thickness a little bit. And now that the buffer is more visible, we can use this polygon to assign no data to anything outside of the buffer, since those areas don't meet our criteria of being within 1,000 meters of a major highway. And so first we want to make sure we have the buffer polygon selected over here in our contents window. Then we're going to go to the grids tab and click assign no data. Then we can select our input grid as the target combo grid that we made, since that has all of our criteria already incorporated. And then our no data polygon boundary is going to be the query results polygon we just made. And when I choose that, Surfer automatically thinks that there's 28 polygons inside of that. But since we made sure to choose just the polygon we wanted in our contents window, when I click selected objects only, now we've got just the 2 polygons that we want. I can also select no data outside so that the no data is assigned outside of our buffer like we wanted. I'm going to add this as a new color relief layer, and I wanted to call this our target final grid. Let's go ahead and add that to the map. Let's collapse these, bring that up. And then I'm going to have to turn the opacity down on our no data so that we can see through to our other layers. I'm also going to turn off this target combo layer. And now we can see that the no data has been applied to everything outside of our buffer. But the layer that we ended up adding that nice color map to ended up not being our final layer. And so to save some time, instead of going through and doing that whole process again, we can actually go back to that target combo layer and open up the color map. And then we press save. And you can name it whatever you want. I'm just going to leave it as out.color. Save it. Close that. Go back to our final layer and open up the color map editor here. Then let's load that out file, apply. And now that beautiful color map that we made on our other layer just got copied exactly over. Okay. All right. And now we're starting to get a really clear idea of our most suitable storefront sites. Let's hop back to this criteria slide, because the last bit that we wanted to include was that the store is located in an area of need that a current store doesn't cover. And we can incorporate this criteria in Surfer by using the Thiessen Polygon tool. Thiessen polygons define individual areas of interest around a set of points. And the boundary of each Thiessen polygon defines the area that is closest to each point relative to all other points. Mathematically, they are defined by perpendicular bisectors of lines between all points. And so like the buffer tool, we need to have our objects that we want to edit selected. So I'm going to go to our store locations layer and then shift click all of our already existing storefronts. And the Thiessen Polygon tool is located in the Features tab right next to the Buffer tool. So I'm going to go ahead and open that up. And now we have the choice to output these as either polygons or polylines. And for this model, we're going to keep it as polygons. And then we can choose to either add these polygons to any of our existing layers or as a new one. And I'm going to go ahead and add this as a new base layer. And we also want to keep our original points, so I'm going to keep that checked. Our original points were our storefronts that are already being incorporated into our model, so we want to keep those. Go ahead and press OK. And now you can see the faint outline of those polygons, but let's go ahead and make those more visible. And now that our polygons are set, we really want to take a look at the area of these polygons and their spheres of influence. By eyeballing, we can see that some of these are clearly a bit larger, like these right here in the bottom left. But not all of them are so easy to determine just by looking at it. So we're going to color code these polygons based on their area. And we can find that information in the attribute table. So once again, let's open the attribute table for this layer. And that's in the map tools section. Open attribute table. And since we just created this layer, the only thing that's in it so far are these polygons. But Surfer has a great functionality in the table here at the top called Add Geometry Attributes. And then when I open that window, you can see that Surfer already is keeping track of information, such as the area and perimeter of these polygons. And we can add that into our attribute table, as well as change what coordinate systems they're added in as. So if you're working in several different maps at once, that's when you would want to use that. But we're only working in meters, so I'm going to leave that as is. And we also really only need to add area, so I'm going to uncheck everything else. And press OK. And now you can see that the area for all our polygons has been added to the table. So I'm going to go ahead and exit out of that. And now that our base layer has attributes, we can use Surfer's Base Symbology feature. Base Symbology allows you to color code or assign symbols to your map objects based on their attributes. We can use this tool by having our base layer selected and then going down here to the Properties window and choosing Edit Symbology. And in our Symbology window, there's a lot of different things you can do that I don't have time to cover today. But if you're interested in learning more about that, we have some great help articles and videos on our support site. And so today we're going to be using classed colors. And so Surfer is going to automatically grab our area attribute since it's the only one in our table. And it's going to bin our polygons into 5 different classes. And if we press apply, we can see that what I said earlier was right. These are our 2 of our biggest polygons, but still this color scheme isn't really that intuitive. And we want the best possible model going to our client. So let's simplify this color scheme. And I like this browns option right here. And then since we're interested in polygons with the largest area, I'm going to open our color map editor and I'm going to click reverse on our color scheme so that the larger areas have color. And I'm going to press apply. I think this looks a little bit more intuitive now, but obviously it's covering the beautiful model that we just made. So let's go ahead and change the opacity, which once again is down here in the color map editor. This time we want the lower opacity to apply to the whole layer. So we don't need to add any extra nodes, and I can just change it to 70 right there. Press apply, okay, okay. And now you can see that now we can see through to our map and the store locations, and we can tell that the darker polygons have our larger spheres of influence, and the smaller ones have a lighter color. And to make this abundantly clear, I'm going to click Add Legend up here in the Add to Map option. That's going to add that to the bottom. So let's just do a little reformatting to make this look good. All right. And now that our Thiessen polygons have been added and we can see their influence, we can tell that placing a store along the lines of some of these larger polygons is going to decrease the pressure on some of these already existing storefronts in a larger area. And also, if you guys remember, we want to place our store in one of these red locations since that's our most suitable. And so placing a store perhaps right here would be helpful. It would relieve pressure on all of the stores in this area, and it falls into our most suitable criteria. Also, maybe somewhere up here would be a good fit. or even maybe somewhere in this really large area of red. This could be like a highly trafficked area since all these stores are so close together. So there would be nothing wrong with adding an extra store right here. And that concludes our example for today. This would now be ready to bring to our client and show the best areas for the new storefront location. Are there any questions before we wrap this webinar up? And while you guys are sending those in, I just want to remind everybody that last week we released Surfer 20, which has the new peaks and depressions map type, as well as some great new 3D view features. I'm going to show you guys some of those real quick here. So this was our original base layer that we started with for this example. I'm going to go ahead and enter 3D view with it. Let's whirl this around so we can see it better. And so now in Surfer 20, we have the ability to add color scales to our 3D view models. And that is a color scale of those contours that we started with. And we also have the ability to change the environmental lighting so that you can really customize how your model looks. And in Surfer 20, we now have the ability to export these 3D view models in VRML, which is very helpful. And if you guys want to upgrade to Surfer 20, all you need is active software maintenance. Software maintenance also gives you access to pre-release features via Surfer Beta and access to our great support team who helps put on these webinars. All right, and it looks like we don't have any more questions at the moment. If something comes up later, feel free to email us here, and we will also reach out to you if there were any unanswered questions. So yeah, thanks for attending, guys. Hope you enjoyed it. It was my first one ever, and thank you.